Hey kids, Flexing Teacher Weber here with part 2 of multiplying integers. Now in part 1 of multiplying integers, we discovered some of the rules for multiplying integers. We discovered that if you have a positive times a positive, that equals a positive. And if you have a negative times a negative, that also equals a positive. And then we also discovered that if you have a positive times a negative, that equals a negative. And if you have a negative times a positive, that equals a negative. Now it's very important to be clear that that applies for two integers at a time. So let's take a look at some combinations here. Let's say we have a positive times a negative times a positive. Well, do this in pairs. So 2 times negative 3. Well, I know 2 times 3 is 6. And I know a positive times a negative is a negative. And we'd be done with that, and then we would multiply that by positive 2. And I know negative 6 times 2 is 12, and then a negative times a positive is equal to a negative. So these rules apply, these ones right here apply for pairs of integers, only pairs. So we want to make sure we multiply in pairs. So if I had a negative times a negative times a negative, I would do for the first pair, negative 2 times negative 3. Well, I know 2 times 3 is 6, but I know a negative times a negative is a positive. And then I'd be done with those, and I would multiply that answer by what's remaining, negative 2. And I know 6 times 2 is 12, and I know a positive times a negative is a negative. Okay, so to summarize the rules for integers, I think we can summarize it like this. Well, I know we can. When multiplying a pair of integers, when I'm talking about a pair, I'm talking about two of them. If the signs are the same, meaning positive times positive, or negative times negative, so if the signs are the same, the answer will always be positive. And if the signs are different, and when I'm talking about different, I'm talking about positive times negative and negative times positive. So if the signs are different, then the answer will always be negative. Okay? And then after that, it's just multiplying the numbers, right? So that's the main rule to remember for multiplying integers. And the last thing I wanted to do was a little problem solving with integers. So this says, find a pair of integers that has a sum of 7 and a product of 12. Now, sum means add. Product means multiply. So this can be a situation where I can guess and check. Now, when I do this type of situation, it's always smarter to guess the product first, the multiplying first, and the adding second, because there's way fewer numbers that multiply to 12 compared to numbers that add to 7. So I know the answer, but I'm going to start off guessing wrong just to show you the process we'd go through. So two numbers that multiply to 12. Well, I'm going to guess positive 2 times positive 6. And I know that equals positive 12. But for this to be the correct answer, 2 plus 6 would also have to add to 12, to add to 7, pardon me, because we have to have a sum of 7. But 2 plus 6 does not equal 7. It equals 8. So this part works, but this part does not. So maybe I will do this. Maybe I'll say, you know what? I'm going to try negative 3 times negative 4. I know that multiplies to positive 12. But for it to be the correct answer, those two integers would have to add to positive 7. And negative 3 and negative 4 adds to negative 7. So this works, but this doesn't. So don't erase your answers, because this is good math knowledge. Seeing all this is good. I think what it is the positive 3 times positive 4 equals positive 12, and positive 3 plus positive 4 adds to positive 7. So both work out to the answers we want. The answer to this problem is 3 and 4. Let's take a look at another one. We want two integers who add to negative 12 and multiply to 27. So we'll guess and check it. And always easier to guess the products first. Okay, I'm going to guess the wrong answer, even though I know the right answer. Okay, I'm going to guess 9 times 3 is 27. And for this to be the right answer, 9 plus 3 will have to equal negative 12. Now 9 plus 3 equals positive 12. So this is correct, but this is not. But this tells us very closely what the real answer is. What I'll have to do is do negative 9 times negative 3. The order of the numbers doesn't matter. Now a negative times a negative equals a positive. And then a negative 9 plus a negative 3, those add up to negative 12. Check. Check. Both parts are right. So the correct answer to this problem is negative 9 and negative 3. I want to see your thinking, kids. Even if you can just mental math it. I'd like to see some thinking. Okay, last one. Give me two integers that have a sum of negative 2, so that means add to negative 2, and multiply to negative 24. Okay. Well, I'm going to start off with the wrong answer. I'm going to guess the product first. I'm going to say, okay, it's a negative product, so it's got to be a negative and a positive number. I'm going to say negative 3 times positive 8. Now I know that multiplies to negative 24. But they have to add to negative 2 as well. If I add up negative 3 plus 8, the signs are different, so I subtract. I have more positives, so the answer is positive 5. This works, but this does not. Okay, what if I did, I don't know, negative 12 times positive 2. I know my numbers are going to have to be one positive, one negative, because the multiplication is negative. Well, negative 12 times positive 2 equals negative 24. That's a check. But negative 12 plus 2, the signs are different, so I subtract. This time I have more negatives, so the answer is negative 10. Nope. Oh, so I need two numbers that will subtract to negative 2. I think I know now. Negative 6 times positive 4. That multiplies to negative 24. And negative 6 plus 4, the signs are different. So I subtract 6 minus 4 and I have more negatives, so the answer is negative. The product works. The sum works. The answer to this problem is negative 6 and positive 4. So, we now have all the rules for multiplying integers, and we now have some time to do the ability to do some independent work with multiplying integers. I hope that helps. That's all for now. Flexing Teacher Weber, out.